So in the last video about Python memory management, we talked about reference counting as a way of managing memory in Python. Now in this video, we are going to talk about reference cycles, a situation where reference counting does not work, and generational garbage collection algorithm, an algorithm using which Python memory manager tackles the reference cycle problem. Let's start with the video. Hey, what is up everyone? My name is Sukanto Roy and you're watching Coding with Roy. So, welcome to the Python interview question series. This is the 11th video of the series. In the last video about Python memory management part 1, we discussed about reference counting. And in this video, we are going to talk about generational garbage collection. Timestamps as always will be in the description. So, if you want to skip to a specific part of the video, feel free to do so. And if you like this content, please subscribe and click the bell notification. It will give me immense motivation. So first, we are going to give a quick refresher about reference counting and reference cycles, and after that we are going to discuss the generational garbage collection algorithm in detail. So a quick refresher about reference counting. What exactly is reference counting? So if you are not familiar with this topic, the best situation is that you go to the last video I created. I'll leave the link in the card and then come to this video. But I'll give you a quick refresher here as well. So reference counting is a simple technique using which Python memory manager deallocates objects that do not have any reference in the program. So the idea is that whenever a particular object reaches reference count of 0, then the object is classified as unreachable and then it is deallocated from memory so that the memory that was consumed by that particular object can be used somewhere else. So what is the problem to the reference counting? Reference counting works great. It is a intuitive and simple solution, but it has a problem, and the problem is a situation called cyclical references or reference cycles, what we call. So reference cycles are very easy to get into in real life, and to understand what circular references are, let me explain you with this particular diagram. So say for example, we have a class called person, and that person class had two attributes. One is name, the name of the person, and another one is a pet. And the pet is a pet object that is a different class altogether. So the person object inside has name and pet, and the pet object itself contains something called a pet name, the name of that particular pet, and pet type, say for example dog, cat, etc., and the owner. And the owner is also a person object. So we are creating a particular person object like this. So we are doing a equals to person, and we are creating a person object. So Python is going to create a person object inside memory heap, and when it is creating the person object, it is going to create a pet object because we will assign a pet to that particular person object as well. So in memory, the person object is connecting to the pet object itself. Now the pet object will also have a connection to the person object, like in this particular diagram. So there is a circular reference. The person object is connecting to the pet object, and the same pet object is connecting back to the person object. Now when we are doing a equals to person, what we are doing is we are creating a variable called a, and that a contains a reference to that person object. It does not contain the person object, as I have mentioned in the previous video how variables work in Python. The variable does not contain the value, it contains a reference to that object. So the a variable is going to connect to that person object, and when you are going to do something like a equals to none or delete a, what it is going to do is it is going to remove this particular connection. So now we do not have any connection, any way of reaching to this person object, and it will, as we do not have any way of reaching to the person object, the Python memory manager should collect that particular object, right? But it does not happen in case of reference counting. Why it does not happen? Because if you see this person object has a reference count of 1, because this pet object is referencing to this person object. And this pet object also has a reference count of 1 because the person object is referencing to the pet object. So both of these objects have a reference count as 1. So the reference counting algorithm will never be able to deallocate this particular type of objects, and they will be in the memory forever. To tackle this problem, Python uses something called generational garbage collection. It is a very sophisticated algorithm using which Python deals with these reference cycles. So in the next part, we are going to discuss about generational garbage collection. So now let's talk about generational garbage collection. So this is a very sophisticated algorithm, and what my philosophy of demonstrating this is, I will first give you a gist of that particular algorithm, and then I'll give you the optimizations, the generation, the concept of generation and the concept of thresholds, and then I'm going to go into the details of how Python internally does the cycle detection. What is the cycle detection algorithm? So what is generational garbage collection anyway? So in simple terms, generational garbage collection is a mechanism using which Python memory manager focuses on dealing with reference cycles. So it is only for circular references, and what it does it internally, the garbage collector, the garbage collector is implemented in the GC module in Python. I'll show you the code examples of the GC module. So the GC module is something that implements this particular algorithm. So the garbage collector tracks each and every object that is present in the memory heap and divides the object into 3 buckets or 3 lists, and each of these lists have a certain amount of threshold. So say imagine it as a bucket. So there are 3 buckets, and every Python memory manager classifies each particular object in one of the buckets, and that each bucket has a particular threshold or a limit, you can say. And whenever the number of objects inside that bucket reaches that particular threshold, the garbage collector collects or deallocates memory based on which is unreachable object and which is reachable object. So whenever an object from generation 0, so the concept is something like this. Whenever an object, so there are 3 lists as I mentioned. So each list is called a generation. So there is generation 0, that is the youngest objects are present in generation 0, and then there is generation 1 and generation 2. Whenever Python collects Python runs a garbage collection round on generation 0, whichever object survives that particular collection round moves to generation 1, and whichever object survives the garbage collection process of generation 1 moves to generation 2. So there are only 3 particular generations in this particular algorithm. So I am sure most of you will not understand anything by this particular thing, but it is a gist. So I did not understand when I read about this particular thing as at first go. So let's dig deep into this. So to understand generational garbage collection, the 2 main things that we have to understand is the concept of generation and the concept of thresholds. And one thing that I have to there are a few pointers that you should keep in mind. So we are going to clarify these particular pointers, but I want you to keep these pointers in your mind. The first is that the main idea behind this algorithm is cycle detection. So the idea of generation is just of optimization. So that is not the core thing. The thing I mentioned, that there are 3 lists and Python keeps object in 3 different lists, that is not the core of that particular algorithm. The core of the particular algorithm is the cycle detection technique. How Python detects if one particular object is unreachable or reachable in this way. So these 2 ideas you should first keep in mind. And the third one is the garbage collector only focuses on container type objects. So they are only objects like arrays, lists, dictionaries, sets. These type of objects that can hold reference to other complex objects are the only type of objects that Python garbage collector focuses on. So it will not focus on integers or strings, these kind of immutable object. It is only going to focus on container type objects. So let's talk about generation. So the garbage collector maintains 3 lists. As I mentioned, there are generation 0, 1 and 2. And these lists are called generations because they keep track of all the objects from just recently created to the oldest object in the memory that are being created by the program, by our program. Now generation 0 is something that is used most frequently because generation 0 keeps track of all the newly created objects, and most of the objects live and die at generation 0. So this is generation 0. If Python executes the garbage collection process on a particular generation, the object that survives that particular process moves to the next generation. So in this way we deal with this particular algorithm. And one thing I again iterate is this is just an optimization technique on top of the actual cycle detection algorithm. So why we need this optimization technique is something that I'll discuss when I discuss the cycle detection technique. So there again, to show you a diagram, so we have generation 0. This contains the youngest objects, and then all the objects that are passing this particular generation goes to generation 1, which is a little bit older, and then it goes to generation 2 that contains all the oldest objects. And the oldest objects, they are going to be there for a long time until the program is finally getting executed, or we are going to collect the full we are going to run a full collection round. So what is full collection round, we'll also understand. When we're doing garbage collection on generation 0 or generation 1, we are called a non-full garbage collection round. And when we are collecting garbage in garbage generation 2, we are going to call it a full collection round. So now that we have understand the concept of generation, let's talk about the concept of thresholds. So a threshold, as I mentioned in the first slide, that every generation contains a particular limit that you can set using the GC module, and in that limit is if a particular count of object goes above that limit, the Python garbage collector runs a round of garbage collection. Okay, so the generational garbage collection mechanism is quite expensive. So due to the cycle detection technique, it is quite expensive to run the full garbage collection mechanism. So which is why, for this reason, it is not feasible to do real-time garbage collection. So the reference counting algorithm that we understood in the last video is something called a real-time algorithm. Whenever a particular object reaches reference count of 0, in some time Python memory manager automatically deallocates that particular object. But this particular generational garbage collection algorithm is not a real-time algorithm. It only runs when there is a certain number of objects that are exceeding the particular threshold of the generation. And to get around this problem, we have default threshold, and the older the list is, the lower the threshold is. So this is one thing that you have to keep in mind. So the generation 0, so let me first tell you, the generation 0 list contains a threshold of 700. So whenever Python memory manager notices that the number of objects in generation 0 crosses 700, it will run a garbage collection round on generation 0. When there will be a when in the case of generation 1 and generation 2, the threshold is 10. When Python memory manager will see that the particular generation 1 is crossing the limit of 10 objects, it is going to run a garbage collection round on generation 0, the generation 1. And one thing you have to keep in mind is, whenever you are running a round on generation 0, only the generation 0 objects are going to be affected. But when you are going to run a garbage collection round on generation 1, both generation 1 and generation 2 are going to get affected. Because whenever you are running a garbage collection round on a older list, it will automatically run on the younger list as well. So when you are going to run a garbage collection round on generation 2, the oldest list, it will run both on generation 0, generation 1 and generation 2. So all three lists are going to get processed whenever you are going to run garbage collection on generation 0, generation 2. So that is why when you are running a full collection round, you are asking about running the garbage collection method on 3 different lists as well. So with that, what we are saying is the older the list is, the fewer we run garbage collection on that, because the older the list is, the objects inside the list are more likely to be reachable. Because imagine it in this way. So if there is a particular object that is passing the garbage collection round from generation 0 list and going to the first list, then that means the object is more likely to be reachable than all the objects in the 0 list. And the object that is in the second list is more likely to be always reachable than the objects in first and 0th list. Okay. So let's start with taking a deeper look at the cycle detection technique. So at first I thought of telling you by explaining this point, but then I decided that there is a great blog that I can use. So this Python internal blog explains the garbage collection in great detail and very thoroughly. So I will use this particular website, and I'll leave the link in the description as well. For this particular slide also I'll share, and all the links I'll share so that you can take a look at it. So this is the cycle detection technique. So see, one fun thing I'll show you. The CPython implements the cycle detection here. So this is the function that internally implements the whole cycle detection technique. Okay, so now coming back to this. So the CPython maintains 2 doubly linked lists. So it is maintaining 2 doubly linked lists, and one list is containing all the objects that are going to be scanned, and then the next list is going to contain be a tentatively unreachable list. Why tentatively unreachable list? We are going to discuss next. So there are 2 lists. One is for all the objects that are present are needed to be scanned. So at first the object that needed to be scanned will contain all the objects, and we are going to process, and whenever we are going to see an object is tentatively unreachable or unreachable, we are going to move that to the second list. So let's start with this particular example. So this is a circular linked list. So say for example we have a circular linked list. So link 1 is connecting to link 2, and link 2 is connecting to link 3, and link 3 back to link 1. And then there is this circular linked list that is going to connect to itself only, no other particular node. And there is an external variable that is connecting to the link 1. So there is an external variable that is referencing this link 1. And when it is referencing to link 1, we can obviously reach any of the particular links between link 1, 2 and 3. So this is the scenario that we are going to dissect. So take a look at this particular thing. So this particular object has 2 reference counts. See, reference count as 2 and GCREF. So what is this GCREF? The garbage collection algorithm internally modifies the reference count. So it does not want the actual reference count to get modified. That is why it creates a copy in the variable gc_ref, and the gc_ref initially becomes equals to the actual reference count of that object. So at this point we have all the object in the list objects to scan, and the unreachable, tentative unreachable object, the list is empty. Now when we are going to, the GC then goes through each container object and decrements by 1 the GC reference of any object it is referencing. So what it is going to do is, next the garbage collector algorithm is going to decrement the GCREF count, which was initially set as the reference count. It is going to decrement by 1, because the main goal of this is to keep only the references that are coming from outside of the list. Understand this point very carefully. So what is inside the list? Only the objects that are linking this particular this linked list objects are inside the list. Only these container objects are needed to be scanned, and this variable a is outside the list. So Python garbage collector only wants the references that are coming from outside, and whatever inside we have all these particular references that link 1 is referencing link 2. So these references Python wants to remove, but it wants to remove the reference count, not the actual references. Okay, so that is why it is going to decrement the gc_ref count, and then we will have something like this. We will have link 1 will have gcref as 1, link 2 will have 0, 3 will have 0, and the link 4 will have 0. Now the garbage collection algorithm will again run the same process on the remaining on the objects. So those objects we will have the gcref count as 0 will move to this unreachable particular list. So in this case, you can see that link 2 has not been moved, because we can see here they are mentioning in the following graph the garbage collector processed the link 3 and link 4. So these things are processed, but it has not still processed link 1 and link 2. So now we have something like this, that link 1 and link 2 are in the objects to can list, and link 3 and link 4 are in the unreachable list. Now we are going to assume that Python is going to see this particular link 1. Let's assume that the garbage collector scans the next link 1 object. It will going to scan the link 1 object, and it will see that the gcref is 1. So obviously the garbage collector is going to mark link 1 as reachable, not unreachable, reachable, because we are able to reach that particular object from an external source. So here we are going to reach that particular object from variable 1. So variable 1 we can use to reach to link 1. So that is why we are going to label it as reachable. So when we are going to find a reachable object, it is going to traverse all the references that are going from that object, and it is going to mark all those objects as reachable as well. So understand this. When the garbage collector encounters an object that is reachable, it traverses the references. So when Python garbage collector saw that link 1 is reachable, what it is going to do is it is going to traverse link 1, and it is going to see, okay, there is link 2 attached with link 1. So it is going to go to link 2, and it is going to mark link 2 as reachable also. But if you saw that gc_ref was 0 for this particular list, so it would have been in the unreachable list obviously. But as we found that link 1 is reachable and link 1 has a reference to link 2, then obviously we can reach to link 2 as well. So it is going to mark link 2 as reachable as well. And similarly from link 2 we are going to go to link 3, and then we are going to see that link 3 is also going to have reachable, is going to be reachable. So at the end of this we are going to see that all these particular object link 1, 2 and 3 are going to be in the list again for the reachable objects. It is going to be marked as reachable, and you can see that the reference count has again resetted to 2, 1 and 1. That was first, and this particular object link 4, there is no way to reach this particular object through any external source. So that is why it will remain in the unreachable list, and it will move to a definitely unreachable list. So this list is tentatively unreachable, and then there is a list called unreachable. If you move that particular object to unreachable list, then the Python garbage collector is going to collect that object, and it is going to deallocate that object. So that is the whole process using which we do the cycle detection. So to reiterate, if you don't want me to reiterate this particular topic, you can move forward. So to reiterate, we will have all the objects in this particular object to scan linked list or doubly linked list, and we are going to have something called gc_ref that is going to first have all the reference count, and then we are going to decrement one count and then see all the references. Whichever reference count is going to be 0 after we decrement the count, we will move that to tentatively unreachable, because we are not certain that it is unreachable. Temporarily we are putting it in a unreachable list to see if it is actually unreachable or not, and then we are going to move the whole process again. Now again we are going to see for link 1 that it is reachable from an outside source. So it is reachable from variable 1, variable A. So that means the link 1 is reachable. So if it is reachable, we are going to mark it as reachable, and we are going to again traverse the link 1 and see what are the references we have. So link 1 is referencing link 2. So we are going to go to link 2 and we are going to mark link 2 as reachable as well. Similarly, we are going to mark link 3. So after that, all the reachable links are going to be in the objects to scan list again, and only the truly unreachable objects are going to remain in the tentatively unreachable list. So we are going to take the tentatively unreachable list and we are going to put it in the actual unreachable list, from where Python garbage collector is going to deallocate that particular objects. So that is the whole process. Now what are the optimization? As you can see that Python garbage collector is taking each and every object and it is going through all the references that object has. It is a very time consuming algorithm. So that is why we have something called generations. So it is where the generation concept is coming from, because we assume that all the objects that are in the generation 0 list will live and die in the 0 list very quickly. So we are going to create that object for particular thing, and within a few seconds or milliseconds we are going to delete that particular object. So it is how we imagine generation 0 to be. So that is why we will keep generation 0, which will run most frequently. So the generation 0, the garbage collection on the generation 0 list runs most frequently. After that, the generation 1 list, when we are going to run anything on generation 1, we are going to run both on generation 1 and generation 0. So it will be a little bit time consuming, and then the final is generation 2, that is the full collection. When we are going to run the garbage collection round on generation 2 list, we are going to run on all the particular list. So 2 and below 2 we are going to run. So that is the full collection process. So let's see some code examples to understand it better. So now coming to the code example, let's see reference cycle. So in reference cycle, let me first import GC, and then we are going to disable automatic garbage collection, because we don't want the garbage collection to automatically run. I want to demonstrate few things, and also this is a particular method that I am using that is using the ctypes module to get the reference count using addresses. So this is a particular method that I created in the last video. I am going to use that, and this is a way to create a linked list, obviously. So I am creating this is a test list, and it has nothing but a attribute next, which is going to reference to a different list. So we are going to first create a list 1. So, and we are going to contain the list ID, because we want to see the reference. When after that we delete it, we are going to see, so we are going to keep the ID at list 1 ID. Similarly, we are going to do it for list 2, but remember, in list 2 what we are going to do is we are going to keep the next as list 1. So the list 1 is going to, list 2 is going to have list 1 has next, and we are going to see the reference count of 2. List 1 is going to be 2, because this list 1 of the variable is referencing to this particular object, and this list 2 variable is also referencing to list 1. So the list 1 has reference count of 2, but list 2 will have reference count of 1, because only the list 2 variable name is referencing to that object. So it will have referencing count of 1. but now we are going to make it a circular linked list. So we are going to put list 1 next as list 2. So understand, list 1 is connecting to list 2 and list 2 to list 1. So we are connecting a circular reference. So now we are going to see the reference count is incrementing from 1 for list 2 to 2. So now what we are going to do is we are going to delete both the variable list 1 and list 2, but it will not delete the object. So now if we see list 1 is not accessible anymore. We cannot access this particular list 1, but we have saved these memory addresses, right? So we have saved list 1's memory address. We can print it here, list1.id. So this is the memory address for list 1. So let's see the reference count. Okay, so it has reference count as 1. Now let's see the reference count for list 2. It has reference count as 1 as well. Why? Because we deleted these two variables, list 1 and list 2. So list 1 and list 2 were referencing to those objects. So those references are gone. Only list 1 object is referencing to list 2 and list 2 object is referencing back to list 1, similar to what I showed you in the slides. So that is why it will have reference count as 1 and 1. Now if we do not enable this garbage collector, we are going to never get this particular objects deallocated. So now let's see the count. So using this get count, we can see how many objects are there in each particular generation. So see, this particular generation 1 has 1028 objects. Generation 1 has 7 objects and generation 2 has 1 object. So you can say that why 1228? Because you said that the threshold is 700 by default, because we disabled the garbage collector obviously. And now let's manually collect. So when we are going to use gc.collect, it is going to manually run a full collection. As I mentioned, the full collection as in 0, 1, 2, 3 list will be collected. So let's run this. So we can see the number of objects that are deallocated. Now we can again run this get count, say, and see. When we run this get count, we have 97 objects and these two generation 1, 2 are gone to 0. Now we can see reference count of list 1 ID and reference count on list 2 ID. Now before I run this, I'll tell you, when you are going to deallocate the particular object, the address can give garbage value. So it can give 1, it can give 0, it can give 10,000, anything, because when you are removing a particular object, the address for that particular object is now free and it can have any other object inside it. So it will not have a consistent reference count. So if we run this, so we can see now it has reference count of 0. So if we run it multiple times, right now it is not getting used. Now we got lucky because now this particular list and this particular memory ID is not being used. So we can see the garbage collection, like the reference count as 0. But if you particularly run this particular code snippet, you can see it giving garbage value. It can give 2, it can give 0, 10,000, 2 lakh, anything, any garbage value. So now we can enable the garbage collector again using gc.enable. Now it will automatically run it. Now let me give you some more GC module exploration. So we can, as we saw, that we can see all the objects that are in each list using get count method. So this is the generation 0 list, this is generation 1 list, and this is generation 2 list. Now we can get the threshold. So obviously the default threshold, as I mentioned, is 700 for the first 0th list, the 10 for first list, and 10 for second list. When I am saying second list, that is mean last list. Now we can do something like this. We can do set threshold of say 1000 and then 20 and 20. and now we can run this particular get threshold as well, and we will see that we have updated that threshold. See, now the threshold is 1000, 20 and 20. Now the full garbage collection, will not run until we reach this particular count. So the count for generation 0 will only going to run when we are going to exit 1000 objects in this way. But let's change it to the default, because you technically do not want to mess with garbage collector in Python. So that is a rule of thumb. You do not, unless it is absolutely necessary, don't do this. And one more example to get gc.getStats to give you some statistics on the number of collections that has been run, collected items and uncollectible items. So that was it for this particular video. I hope you found this video very helpful. I hope you understood how Python does generational garbage collection and what are the nitty-gritty details of that particular algorithm is. And if you found it valuable, please subscribe to this channel and please hit the bell notification so that you get notified whenever I make any such videos. So thank you, and like, comment your suggestions for the upcoming videos, and obviously subscribe.